My projects for this semester are chosen with a tennis ball collecting robot in mind. My goals for Project 1 were to program a tennis ball detector and implement that program into a robot platform. The first step in the project was implementing the detection. I implemented the detection in Python using the OpenCV Computer Vision library. My approach for the project was to detect the defining characteristics of a tennis ball, so namely the color and the shape. Tennis balls are normally yellow or green in color, and when you project them to a 2D plane, they're circular in shape. As a result, the program checks for these characteristics. So the program will take a given image and filter that image for yellow and green to produce a mask. This mask is then applied to the original image to isolate the yellow and green colors. With this image, I then run half circle detection to detect circle centers and their best approximate radii, and then draw the circles onto the original image. With the detector done, I then move to integrate it with the robot. The robot used for this project is Hiwonder's JetHexa hexapod robot. The features of the robot relevant to this project are its mounted camera and its implementation in the robot operating system, also known as ROS. Specifically, this robot was implemented in ROS Melodic, which was the ROS distribution just before official Python 3 support. This is important to note because that means I had to use Python 2 for the project because some of the packages used were incompatible with Python 3. One of the defining features of ROS is its ability to allow programs, also known as nodes, to communicate asynchronously through publishers and subscribers. A publisher will generate some message with data and publish it on a topic. Subscribers will then subscribe to that topic, receive the messages therein, and then use the data within those messages for their own purposes. So to quote-unquote ROSify the project, a photographer node takes images from the robot's camera and publishes it to an image hub topic. A subscriber node then subscribes to that topic, receives the image, and then runs the ball detection algorithm. However, the OpenCV image format is different from the image message ROS uses, so I used the CV bridge package to bridge the two. To ensure I could send and receive images properly, I ran a test. I published multiple randomized images onto the image hub topic and tested if the subscriber could take those images and display them. We see that if the publisher stops sending images, the subscriber continues to listen to the topic. It displays new images when the publisher resumes. From here, it was just a matter of plugging the pieces together. On the publisher end, I capture images using the JetHexa's camera and publish those images to the topic. The subscriber then gets those images and runs the ball detection algorithm. When the program then reaches the predefined threshold for consecutive detections, it then considers a ball to be truly detected. This is done to help prevent false positives. So while the program does detect tennis balls as desired, there are some areas of improvement. For one, the efficacy of the color thresholding is dependent on lighting. As we can see in this clip, the ball that is further away from the robot is initially undetected, but with the lighting change, it becomes detected and also introduces some false positives on the left. The false positives can potentially be handled through a combination of thresholding and parameter tuning. On the lighting end, it may be effective to implement an environment-based color filtering. So for example, the user could pass a Boolean value to tell the robot that it's outside and use a specific set of color thresholding parameters for that environment versus another set of parameters for the inside condition. This would give the program a bit more flexibility in terms of environment. Another potential improvement could be the implementation of a machine learning approach. This could help curb the detection of those yellow or green circular objects that are not tennis balls. Looking toward Project 2, my goal is to be able to calculate the angle between the robot and the detected ball and have the robot make adjustments to face the ball head on. Thank you for watching.